Hello and welcome again to this video tutorial. In last video tutorial, we just learned the assignment operator and a conditional operator. In this video lecture, I'm going to present the bitwise operator and another operator which covers the comma, size of operator and typecasting. So now let's begin with the bitwise operator. So now the bitwise operator, it, it works on the basic level. In other words, means at the storage level. So now before learning the bitwise operator, we should know that how your computer is going to store your values. So if I'm going to take the example of this int a, b and c, the computer is going to convert these decimal values to the binary values, and whenever you're going to store some negative value, that is going to stored in the second complement. Now, if you want to need some more input regarding this, you can comment under this video, and I'm going to make a separate video for that. Now, let's stick to our bitwise operators. So now I'm having these three variables, and I'm assigning the value 4, 4, and 5 respectively to A, B, and C. So now, if I'm going to write cout A and B. So now remember that now in this particular case I'm using a single symbol of a AND. If I'm using a two symbol of AND consecutively, that represent a logical AND operator. But here this is a single AND, it means it is a bitwise operator. So now let's make some binaries for this. The binary for a 4, that is equivalent to, so I'm going to use the notation 8 4 2 1. So now how 4 is going to be meant? So 4 is 1, rest are 0. So binary equivalent of this 4 is 0 1 0 0. So this is binary equivalent of 4. And same the binary equivalent of a 5 we can calculate in similar fashion, that is 4 plus 1 5. It means these two values are true, it means 0 1 0 1, so it will become 0 1 0 1. So now if I'm going to do A and B, and means both are true, so it means I'm ending 4 with a 4, it means the corresponding value is going to be added, and I will have a same output on the screen. So till now what I did, I just did a binary and to this, so that will give me, so like uh, 0 and 0 is a 0, and 0 and 0 again, it's going to give me a 0. 1 and 1 is again a true, and whereas 0 0 is 0, so it's again equivalent to 4. So that's why we are having a 4. So now let's try it with a C. C is a 5. So now I'm saying that A and C. So now you can see that here I'm having a different value, and this is a 1. So and means both would be true. So here is a 0, here is a 0. Only here we are having a 1. So at the third place, so it means A and C will give me the 4 as a output. So this is how our AND operators work. So similarly, I can demonstrate the OR operator. In the OR operator, either of a bit would be true, and then the resultant bit would be true. So here, if I'm going to apply OR over here, so first bit is my set, it is true, it means 1 is true, second is 0, and again this third bit is true, it means 4 and 5, 4 plus 1 5, 5. A or C will give me the 5 in this particular case. So if you are having a confusion with that, just comment it and I will make a separate video for that. So the next one is bitwise XOR. So if I'm going to put this, so it is going to XOR the operation. So now this XOR is having a 1 as a output. So now XOR is work whenever we are having a different these values. So here 1 and 1 it's the same, 0 and 0 is same, here 0 and 0 is same, and here we are having a different value. So XOR will have a 1 as a output. Similarly, this is a bitwise ones complement. So now how ones complement is going to work. So let's take a simple example, a equals to 2. So now this is a little bit tedious because that's why I already defined that how the computer is going to store these values. So until now we have worked with the just binary equivalent of a decimal. So now here a equals to 2, and if I'm going to put this one's complement on a, now let's see the what will happen. So a is a 2, so 2, this is decimal, that is equivalent to this binary. So 2 is this one, 0 0 1 0, only second bit is true. So now if I'm going to execute this, so what it going to do, so it's going to negate, actually it's going to store in this manner, and now it's going to convert all the digits. Instead of 0, it's going to put 1 1 1 1 1 0 1. So actually this is our output. This would be our output. So let's compile this, and you can observe -3 is our output. So now this is actually equivalent to -3. How? Let's learn this, that how this is -3. Okay, so now among all this value, these values are reserved for the data, and this first bit that is used for the sign bit. If it is 1, then it means it's a negative number. If this 8 bit that is 0, it means that is a positive number. So now let's represent 3 in a binary. So your 3 in a binary equivalent to 2 1 3, 2 plus 1 3, so it's 3 4 1, okay, 2 1 3. So this is your binary equivalent of a 3. So now first we are going to take a ones complement to this. So your ones complement would be inverting all the digits. Okay, so it's 1 1 0 0. So this is ones equivalent. So now to find the seconds complement of this number, so I'm going to add 1 in this. So this will remain as it is, so it's a 0 1. So now this is your required storage of -3 in a seconds complement. So you can see that is equivalent to the same whatever we have observed in the output, -3. Okay, now the next two are the shift operators. So let's go through the same code. Now instead of this, I'm going to shift this thing 1 to the right. So this, sorry, left. So this is a left shift operator. So it is going to, okay, so now my binary equivalent of A, that would be, so this is your binary equivalent. So now left shift means I'm going to insert a 0 and whole these values is going to be shift to the left side. So this one will take the third position. So at a third position, 1, 2, 4, it is a 4. Now let's see what is in our output screen. So it's a 4. So now if I'm going to do a right shift by 1, so it means 1 is going to be moved to this right hand side. So this is going to be placed over here. So here we are having a 1. So now we are having a 1 as a output. So now similarly you can do this thing. Okay, so I'm going to represent this 8, 4, 2, 1. Okay, so now if I'm going to left shift the bits by 2, it means this is going to shift it over here and over here. 2 times I'm going to shift it to the left side. So now the position of this 2, this 1 bit, true bit would be 4th location, 1, 2, 3, 4. So 8. So I will have a 8 in this particular case. Now similarly, you can shift right by the as number of steps as you can. So now after that we are going to learn these some of the operators in the next video. Thanks and keep tuned.